Okay, so in the previous parts, we have seen permutations of distinct objects. Now we are going to tackle the situation where we don't necessarily have distinct objects. So let us start with an example and see what we can do here. Say we start off the way we started permutations, that is, we take a word. Now you see that the letters of this word are not distinct. Namely, O appears twice. So if instead of treating these two O's as the same thing, if we treat them as different O's, suppose O1 and O2, for a moment let us say that we treat them as different objects, then how many permutations we will get? Let us just once more write them down. We already know this, but let's just write them down. And we want to see how many permutations we would have got if we had four distinct objects. Actually, we know 24 of them, but in this particular case, what happens, we want to see that. So this is one of them, of course. Then we can write the other ones the way we write O2 R T O1 O2 R T O2 O1, then R O2 T O1 R O2 O1 T. Have I missed something? Oh no, yeah, 6 of them. Then I have O1, say O1 O2 R T, O1 O2 TR, O1 T R O2, O1 T O2 R, O1 O2 T, so I have to write R here, O1 R T O2, O1 R O2 T. Okay, then we can start with O2, O2 R O1 T, O2 R T O1, O2 T O1 R, O2 T R O1, O2 O1 T R, O2 O1 R T. And finally we will have one more column. So there we will start with T, O1 O2 R, T O1 R O2, T R O1 O2, T R O2 O1, T O2 O1 R, and finally T O2 R O1. Okay, so these are the 24 possibilities we have if we do not, if we do distinguish between these two O's, writing them as O1 and O2. Now you can see actually what is happening here. I really have the same O. So if I look at some of these permutations, I will see repetitions. Repetition in the sense that the same permutation will appear twice here. For example, now having written all these things, if I now decide to not distinguish between the O, then what shall I get? Say for example, for this one and this one. You see, they give rise to the same permutation, ROOT, root. Okay, so if I count the number of permutations in the usual way, without caring for the fact that there are two same objects, then I am actually counting twice. is it the case that I am counting twice for all the permutations? Actually, this is the case because you see, in any permutation, R and T are appearing somewhere, O1 and O2 are also appearing. So in one of the permutations, I am writing O1, O2. In another one, I am writing O2, O1. We can check this with other permutations. You see, ROTO. Now somewhere ROTO is again appearing. See, RO1T1, RO2T1. So instead of writing O1, O2, I am writing O2, O1 also. So that gives me twice the number of permutations that we should have. Okay. You can check the others also. You see, for example, these two, RTO1O2, RTO2O1, they actually give rise to the same permutation RTOO. Right? So whatever we are doing here, we are doing it twice. We should not do it twice. So instead of having usual 24 permutations, we will now have 24 divided by 2 equal to 12 permutations. And those 12 permutations are obtained by identifying or obtained by simply not distinguishing these O's. Okay. So if I just remove the suffixes, then I will see that I get the same permutations twice, 2 times. Root, ROTO, ROTO, RTOO, RTO. The same thing will happen here also, here also, here also. Okay, and the reason is that because I am distinguishing the O's, I am counting everything twice. Since the O's among themselves can be arranged in 2 ways, so that is giving me twice the required number. So that's why my actual answer should be 12. Now in this case, O is appearing twice, so that's why I am dividing by 2. But if something else happens, what should I do? I mean, I have to figure out from this situation what to do. I am sure that we are sure that the number of permutations will be less than what we originally get when we have distinct objects. But in this case, since distinctness is not there, so some permutations will be counted more than the number of times they should be counted. So that's why the actual answer will be less than what you originally get if you have distinct objects. But then we are, in this case, we are dividing by 2. In general, what should we do? So let us take some more examples and see what happens. Here 2 O's are there. In some other word or in some other list of objects where maybe some objects are appearing more than once, that something else may happen entirely. So we want to see that. Say, for example, instead of this word, if I have another word, which of course is, it should not always be a word, as I have already told you. We are only concerned about the number of permutations, not the nature of the objects. So I imagine a word like this. Okay, REEE, there is nothing like that, but still I am imagining it. And there are 3 E's in this case, right? So if I try to distinguish them using suffixes, then I have like this. For R, I need not do anything because R appears only once. Now you can see that if I try to write all the permutations, here also there will be 24 because there are 4 distinct objects. Now that I have distinguished these E's separately, I can identify them separately. Now the number of permutations will be 24, but originally it's not so. So we have to figure out by what number we have to divide so that we get the actual answer. And actual answer, by the way, is not known to us at this moment. We have to figure that out. So what we do, if we write all the permutations, say R, for the sake of understanding, let's just write it quickly, okay? R E1, E2, E3, R E1, E3, E2, R E2, E1, E3, R E2, E3, E1, R E3, E1, E2, R E3, E2, E1. This is one. Then E1, R, E2, E3. Now the scheme I am following here in writing these is not the usual scheme where I keep the first element fixed and then write the things. I am writing it in a slightly different way. Okay, I am keeping R fixed all the time. In every column I am keeping R fixed, but the position of R will change. So E1, R, E3, E2, E2, R, E1, E3, E2, R, E3, E1, then E3, R, E1, E2, E3, R, E2, E1, and then in the third column, E1, E2, R, E3, E1, E3, R, E2, E2, E1, R, E3, E2, E1, E3, R, E3, E1, R, E2, E3, E1. No, I think I have made a mistake here. E1, E2, R, E3. Till this it was okay. After that I made a mistake. E1, E3, E2, E3, R, E1. I said I was going to use a second scheme, but I started using that first scheme of writing itself. So that was the mistake. Here R appears in the third column, and in the third column itself R is appearing in the third column. Okay, E3, E1, R, E2, E3, E2, R, E1. Finally, in the fourth column, R will appear in the fourth column. So it's just E1, E2, E3, R, E1, E3, E2, R, E2, E1, E3, R, E2, E3, E1, R, E3, E1, E2, R, E3, E2, E1, R. So these are all the 24 permutations if the 3 E's are considered as distinct. Now you can see that if we do not consider them as distinct, if we consider them as the same, then the first column, these 6 permutations that we have got, actually they give me only one permutation. If we do not distinguish between among the E's. Here also, these 6 permutations give me only this. The third column gives me EE, RE, and the fourth column gives me triple R. So in this case, the actual number of permutations is only 4. Okay, the actual number is 4. But what we have, the number that we usually get is 24. So it seems that we have to divide by 6. But why? Why should we divide by 6? Of course, because these 6 entries in each column, in all the columns, they give us the same permutation actually. But why is that happening? That is happening because we have decided to treat these e's as different, and then what happens? We are considering the arrangements that they can have among themselves. Okay, which is the number of such arrangements is what? And the number of permutations of 3 distinct objects is 6. That's why we are counting 6 times. We should count only once, because these, in whatever way you write, even if you hypothetically think of this E as one E without thinking that actually it is different, if you write this E here, this E here, the permutation does not change. It stays the same. Okay. Change means it should be recognizable. This, if I write this E here, nothing actually changes. Okay, the two permutations are one and the same. So that's why this 6 is appearing. And that's why we have to divide by 6. So previously we had to divide by 2 because 2 O's are appearing. In this case we are dividing by 6 because 3 objects are appearing, or one object is appearing 3 times. And what is this number? This number seems to be the number of arrangements of those objects or that same object. How many times we have them in that word. Okay. So it seems that we have to divide by that. But if actually something happens like this, let me take one more example. This is clear. Here we have divided by 6 because that many ways we can arrange these 3 E's. Previously we divided by 2 because there are 2 ways of arranging 2 O's, O1, O2, O2, O1. But in this case there are 6 ways of arranging 3 E's. That's why we have divided by 6. And why we divide by it? It's because that many times we are counting more. We should not count that many. Okay, now let us take one more example where 2 letters are repeated. Okay, instead of repeating only one letter, we now have say 2 letters. And here also I am taking an imagined word which is actually not a word. It's just a juxtaposition of letters. Say A, B. Now in this meaningless word, 2 A's are appearing and 2 B's are appearing. Now what should I do? If I list in the same way, if I list the permutations distinguishing between these things, treating them as distinct objects, then what are the possibilities I get? A1, A2, B1, B2. Then I can write A1, A2, B2, B1, or I can change the first two, A2, A1, B1, B2, A2, A1, B2, B1. Okay. Then in another column, I can now change the positions. I can write like this: A1, B1, A2, B2, A1, B1, or not A1, B1, A1, B1, A2, B2, then I can write A1, B2, A2, B1. I have swapped B1 and B2. And I can swap A1 and A2 keeping B's fixed. Fixed means this arrangement. A2, B1, A1, B2, and then I can swap both A and B. A2, B2, A1, B1. But this can also be written in some other ways also. At this point it's not clear. Let's just try to write all of them. Okay, then AB, AB. We can then also have B1, A1, A2. The A's stay together but the B's get separated. B1, A2, A1, B2. B2, A1, A2, B1. B2, A2, A1, B1. Besides this, okay, I have taken too much space to write this. Anyway, we will manage somehow. Then after this, I can have BA, BA, B1, A1, B2, A2, then B1, A1, no, not B1, A1, B1, A2, B2, A1, then B2, A1, B1, A2, B2, A2, B1, A1. Okay. So A, B, B I have, A, B I have, B, A, I have, B, A I have. And I can also have B, A, B1, B2, A1, A2, B1, B2, A2, A1, B2, B1, A1, A2, and B2, B1, A2, A1. Okay, this means one more should be there. What is that? It starts with, it has, okay, let me see, A, B, I have, A, B, I have, then B, I have, and B, A, B, A. Oh yes, A1, B1, B2, A2, A1, B2, B1, A2, A2, B1, B2, A1, A2, B2, B1, A2. Okay. I have written it in a slightly, you keep in mind that this is the same number of permutations, 24. I have how many columns? 1, 2, 3, 4, 5, 6. In the 6 columns, in each column I have 4 permutations, so 6 times 4, 24. But here also we can see that the first column is actually giving me only one permutation, which is this. The second column is giving me this, AB. These 4 distinct ABs are actually not distinct if we do not consider the suffixes. They turn out to be the same. Okay, see, AB. So we have counted them 4 times, but actually we should count them only once, or count it only once. This also gives me BA, and this one gives me BA. Here I get BBAB, or sorry, BBAA, and finally AB. B, A. So here the total number of permutations really is the number of columns, which is 6. Now from 24 we get 6 by dividing it by 4. But why 4? It's because the number of ways we can arrange these two A's is 2. For each such arrangement, the B's can among themselves be arranged in 2 ways. So the A's as well as the B's can be arranged among themselves in 2 times 2 equal to 4 ways. So that's why we are dividing by 4, because we are counting A's twice, and for each such count we are counting the B's also twice if we are writing the permutations like this. That's why the actual result is amplified, is magnified by that factor, and that factor is 4, by which we should divide. Okay, because we have started our investigation by considering only distinct objects. So the first number we will always get is the one where we consider all the objects as distinct. Then we have to make adjustments. We have to take into account this situation where how many times a given object is repeated, that then we will consider, and we have to divide accordingly by the appropriate number. So this is the technique, and using this technique you can now see the general situation. I will now write that, and then we will move on to some problems. The general situation looks like this. Let there be n objects. Let there be n objects. Not necessarily distinct, but actually some of them are repeated. Okay, the general one will be somewhat difficult to, not difficult, but it will look complicated if I phrase that, say some object is repeated p1 times. Instead of that, let us take a bigger but special case, not a general case involving variables. You see, what many students often make the mistake in mathematics by considering the general situation first. What they will do, they will start by considering any equation involving variables, and then they will just wonder what the equation means, or something like that. Instead of that, this is a piece of advice I got from one of my teachers. She said that whenever you don't understand something which involves equations, generally in mathematics when we encounter results, the result is always about a class of objects rather than a single object. For example, when I say that for any positive integer n times n plus 1 is always an even integer. This is a simple result. One can prove that this using induction, say. Now I am saying something about all positive integers n. Now if I don't understand this statement, what I will do, I will take special cases. This is a general case which is actually infinitely many statements. When you put n equal to 1, this says that n times n plus 1 is a positive and is an even integer. When you put n equal to 2 also, it says that that one is also an even integer. Similarly, it says the same thing for all positive integers. So statements involving variables are actually infinitely many statements involving constants. Okay? And if we don't understand the general statement, we have to consider special cases where we take some constant value of the variable, say 1 times 1 plus 1, which happens to be 2. Okay, 2 times 2 plus 1 is 2 times 3, which is 6. Now all these are even. But why are they even? Because when n is a positive integer, it is either even or odd. In the first case, n is odd. Now if you add 1 to an odd integer, it becomes even. So that's why this product is even, and that evenness is coming from this factor. Whereas if your n is even, then of course the product is even. You don't have to even think about it more than this. You don't care about this factor. It's going to be odd, but we don't care about that. So that is why this product is becoming even. So if we look at this at once, we may not understand what is happening or why this is even, but just by considering two special cases, we can figure out. Okay, in this case, two special cases. For something else, we may need to consider some general case. So that's why I am saying that instead of writing the general formula where say an object is repeated p1 times, then another object is repeated p2 times, I give you a special situation like this. Say this is a hypothetical word. Now for this word I have to find the number of permutations. You see here A has been repeated several times, B 3 times, D 6 times, things like that. So now from the understanding that we have got by considering those examples, I can now write the number of permutations. How many objects are there? 1, 2, 3, 4, 5, 6, 7, not considering them as the same, okay, considering them all of them as distinct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So 15. So 15 objects, had they been distinct, the number of permutations would have been 15 factorial. Recall that it's actually 15 times 14 times 13, and it will go like that till it hits 3, 2 and 1. And why is that? Always keep in mind the process. You are filling in the boxes. So for the first box we have 15 possibilities. Once something has been chosen, oh, that too without repetition, that should be kept in mind. Then I have 14 possibilities left for one such choice, so I multiply by 14 and that way we are getting. So this is 15 factorial, which is extremely huge number. We don't need to care about what the actual number is. We need to care about the process, but we won't get this many permutations because the objects are not distinct. A appears 5 times, right? So these A's, if I consider them as distinct, they will permute among themselves and they will create more permutations than what we actually get. So we divide by 5 factorial because in that many ways these A's can arrange themselves. Okay, 3 B's will arrange themselves in 3 factorial ways and 6 D's will arrange themselves in 6 factorial ways. And why are we multiplying these numbers in the denominator? Because for each arrangement of these A's, B is getting arranged in 3 factorial or 6 ways. For another arrangement also the B's are arranging themselves in 6 ways. So that's why we are multiplying the numbers by the fundamental principle of counting, okay, or multiplication rule. So this is the number that we get. So when objects are not distinct, the number of permutations is reduced, and we have to accordingly divide by a number, which is what now you know. Okay. Now with this understanding, we now move on to some problems where we may or may not have repeated objects, but let us see. Or before going to the problems, let us take an example. So you consider this word institute. Okay, here say we want to find the number of permutations of the letters of this word. Now, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, considering them as distinct, we get 9 factorial permutations. But that's not the case, because I appears twice. So, we have to divide by 2 factorial times. N appears only once, that is okay. S also appears once. T appears 3 times. 3 factorial.